Today we're going to be having a look at set builder notation. So what set builder notation is that it takes a number or a set of numbers and it writes it in an algebraic form. So if we have a look at this example of a number line that we have a minus 1, we have a 3, we have a closed dot and a line and another closed dot. So what that represents is that the closed dot represents including, and the line says that we are including all the points between minus 1 and 3. So if we are to write that in set builder notation, the first thing we need to know is what are our values. We need a start value and an end value. So our start value will be at minus 1 and our end value will be at 3. We know that because of this line and these dots, it tells us that our set of numbers lies between these two endpoints. So x must be between them. What we also know is that this says that we want all the numbers less than 3, and this tells us we want all the numbers greater than minus 1. So this stands for x must be less than 3, which shows us going this way, but there's a stopping point, and that's at the minus 1. So at the same time when x is less than 3, it must also be bigger than minus 1. The round dots or the closed dots tell us that we are including these values, so our inequality signs need a line underneath. So that's your basic inequality. The rest is easy. All we do is we have a squiggly brackets, which stands for the set. We say x is the value that we are working with, and we put a semicolon or a slash, and then all we do here is we need to add a restriction, and what the restriction is, if it's a solid line, is that the restriction is that all the numbers that are between minus 1 and 3 are included. So we have a real number set, and this is then our set builder notation. So just to revise, we need to have an endpoint, or our two endpoints, which is a minus 1 and a 3. We know that our set of numbers, so x represents a set of numbers, must be between minus 1 and 3. The closed dots tell us that we must include, so our inequality signs must have a line underneath to represent an equal sign. And then this line represents all the numbers between minus 1 and 3. So that's not just whole numbers, it's fractions, it's 1, 1, 0, 0,0009. So every single number on the earth between minus 1 and 3 is included, and that's where we say it is included. So the x must be an element of the real number system. Okay, fantastic. If we move on, we have a look at interval notation. So interval notation is quite similar, but it's a lot more simple. All that interval notation says, it says where do we start and end. So we can see here we start at minus 3 and we end at 4. So all we do is we write it minus 3 semicolon 4. Now what's different is that we don't need inequality signs in interval notation. All we need to know is, do we include our last value? So a closed dot says it does. So I have a square bracket for including, and minus 3 is an open dot, so we not including, and it's a round dot. And the only key to interval notation that you need to remember is that we can only write interval notation if x is an element of the real number system. So what that means is, for example, if we had a number line, let's just draw one, and it just had dots, like so, 1, 2, 3, and 4. We'll just include them all just to make it. So that says that we are only talking about the set of numbers. Let's change colors. 1, 2, 3, and 4. There are no other numbers in our set. We are not talking about all these numbers in between here. We are just talking about whole numbers. So, in this instance, we cannot write that in interval notation. We can only write it if x is an element of real numbers, and how we know that it's an element of real numbers is if there's a solid line between our 2 points, between our start and end point. Fantastic. I hope that helps with distinguishing between interval notation and set builder notation, as well as how to write it. So just to summary, interval notation. So just to create a summary, interval notation, the main points is we use brackets. So round brackets for not including, or square brackets for including, and we have number lines that have solid lines so that we have this real number system. Okay, that is the only time we can use interval notation. Set builder notation, we use squiggly brackets to represent the set. We use inequality signs to represent where the set of numbers lies between, and we add a restriction as long as it makes sense. So natural numbers, real numbers, whole numbers. So there is we can do set builder notation on any number line, whether it's with real numbers, whether it's with natural numbers, whether it's with whole numbers, whether it's with integers, doesn't matter. As long as we know where we're starting, where we're ending, and we use our inequality signs to show where the set of numbers lies between. We use squiggly brackets to show that this is the set of numbers we are talking about, and we use one of these restrictions to say in this number set that we are talking about, the numbers that we are using are restricted to one of these real number systems. Interval notation, we just use brackets with a start and an end value. Round brackets represent not including, square brackets represent including, and the big thing about interval notation is that we can only do interval notation or write number sets in an interval notation if it is a real number. So a solid line or the restriction has been given to us. X must be an element of real numbers. Thank you, and I hope this has helped. And we'll be sure to see you next time with some more simple summaries on algebra. So here we have two examples of interval notation. We know it's interval notation because it's only got brackets and variables and numbers between those brackets. And what they want us to do is to write this interval notation as set builder notation. So we'll start with the red one, where t is an element of -2 1/3 and 6. the square brackets mean including. So what we know is that firstly we're working with the variable t. And we know that we have the value 6 and we have minus 2 and a third. What we also know is that the square brackets represent including. So we know that obviously 6 is bigger than minus 2 and a third, so t lies between those two numbers. So we're going to have like that and like that. So this says to me that t must be less than or equal to 6, but at the same time it must be bigger or equal to minus 2 and a third. And then all we do is we say, so that's our inequality. All we need to now is add a restriction, and we know that interval notation can only be written for real numbers. So we know that t is an element of the real number system. We need squiggly brackets, and all we add at the front is to say that t is the variable that we are using, and we oh, those are not nice squiggly brackets. Let's just erase that quickly. So we know that t is the element that we are using, and there's our squiggly brackets. And that is converting interval notation into set builder notation. So let's have a look at this one. Well, if we had to put this on a number line just quickly, what we would get is that we know that the number line is this way, 2 is our biggest value, and we have this thing over here which is negative infinity. So the reality is that negative infinity isn't an actual number. It just means that it's so far towards the negative numbers that it's not an actual number. It's just a really, really, really large number. So we know that it's including, so we have a closed dot, and we know that it wants numbers less than 2, so just going that way. But because there's no endpoint, we just have an arrow. So if we are now to write this in set builder notation, well, we know we need our squiggly bracket. We know that the variable we're working with is y. We also know that the numbers that we want, all they need to be is less than 2. So that's quite simple. We can say, well, y must be less than or equal to 2. And the restriction, once again, because it's in interval notation. And there we have it. Set builder notation for both of those examples.